Hope you guys are doing well. So, continuing on our journey, today we would be starting with TCP. Oh, sorry, we would be entering the transport layer. The transport layer is basically responsible for end-to-end communications between applications. It ensures that data is delivered accurately in order and there is no duplication, right? So basically, we are at the transport layer in the TCP/IP stack. Above the TCP IP, above the transport layer, we have the application layer, and then we have the IP internet or network layer, which basically does the IP addressing, right? We already saw IP addressing, and so now the only thing that is left is to understand how the TCP or the transport layer protocols, and then we will see a real world example how everything is working around, and then we'll try to go on from there. Okay, so the TCI transport layer, basically we are at the we are at now at the um, basically we are at the transmission control protocol. We are at the transport layer. So the one of the important protocols at this layer is basically transmission control protocol. So it is basically transmission control protocol, also called as TCP. And then we have one more protocol called as UDP, right? So now, uh, so we'll understand the differences between both these protocols. We'll also see what to use when, and then we'll see some details. We'll go on from there. So TCP. So first, so transmission control protocol, or TCP as we call it. Transmission transmission control protocol, or TCP as we call it. Now basically this is a connection oriented protocol, and this is for reliable delivery. Now it is going to work hand in hand, works with HTTP, right? Works with HTTP. So now there is a very famous thing that TCP does, right? It does the three-way handshaking, right? So how is the connection basically going to establish? Is basically we are going to do the three-way handshake process. So let's see the three-way um, handshake process. So as we are saying that this is going to be a connection oriented protocol, so we'll be performing something called as the three-way handshaking here, which is very important to TCP. We'll see. So how does it work, right? So let's take an example. Suppose this is my client side and this is my client. Okay, and then this is okay, and this is and this is my server side, right? So I have two things over here. One is I'm at the client end, and then the other is basically I'm at the server end, right? So now what is going to happen is the server sends the packet. The client wants to start a connection, right? So the client will send first sync packet. So here is my client going to send the first sync to the server, Now the server receives the syncs and then sends back with a sync and an acknowledgement flag set, right? So the response is going to be SYN plus ACK. That is basically acknowledging um, um, that the packet or the request was received. Now then the server will the client will then send an acknowledgement, right, saying that your acknowledgement was received. And once this so we are sending three requests here. So since this is so first is my SYN going out, right? So since this is basically a three-way process that is going to happen, hence we say this is called as this is nothing but my three-way handshake, right? So first is basically where I said my SYN, then I have my SYN plus ACK, and then I'm going to send my acknowledgement. So this process is nothing but called as three-way handshake process, right? So this process is nothing but my three-way handshake. Now, so this is a very famous way of establishing connection, right? So basically, a connection will be established. So now, once this last acknowledgement is received from here, then I'll be establishing my connection. So then I will say a connection is established. Now, so this is basically how the three-way handshake works. Now, this is basically establishing the connection, right? So there should be another way for in when we are going to terminate the connection. There should be some mechanism, right? How does is a communication going to end, right? So now what is going to have is what so the way this is how my connection is going to establish. So this is for connection establishment. So this is connection, or in other words, this is how we are going to establish the connection, right? So now we have basically something called as termination, right? So basically, when we want to terminate the connection, so when we want to do TCP termination, right? Or we want to end the or close the connection. Okay. So again, I'm going to be having two things, right? One is my client, and then other is going to be my okay. So then this is I'm at the client side. This is my client, and then this is my server, right? So Java of the server is basically to serve. So now, so client is going to send to server a finish, right? So I'm going to say I'm going to send in your finish, not to this. What the server is going to do is the server is going to acknowledge this finish and then send an acknowledgement back, right? So an ACK is what is going back. Now then now when the server is also so then the server acknowledges the finish, right? So this is the acknowledgement for this. So now when the server is done sending, it will also send its own fin. Then now after this, the server is going to send its own fin. This is my um fin that is sent by the server. Now the client sends a final acknowledgement. So then now the client is going to send a final acknowledgement. So now I'm going to send my final ACK, right? And then I'm going to close the connection. So basically this is a four-way process. 1 2 3 4. Since this is a four-way process, hence we are saying that this is a hence we say that this is a four-way handshake that is happening, since we are sending in four different messages, right, to end the communication. So once that is done, then the connection is fully secured, and the connection will be ended, right? Now let us see how from the application layer how we are going to go to the TCP. We are going to do, so basically we study different layers, right? So our TCP IP model had different layers, as we said. So this is the most practical form of how networking is going to work. The first is basically where I have my application layer, or where my application is running. So this is basically my I'm at the application layer. Then in the next step is basically something called as my, so there are basically four layers, right? Okay, so let's see. So first is basically my application layer. Then is basically my transport layer. Now this is going to work on top of my, and the next one that is basically my network layer, right? And then is the physical layer of how the physical connection is being established. So basically this is now before going to the physical layer, there is something called as data link layer as well. So before this we will be having a data link layer as well, where we will be performing error correction. So this is basically where we will do error correction. Basically we will be using some Hamming codes or something. So we have this layer as well that is placed above. Now, so now let's see. So the application layer protocols that we have is basically HTTP, or say basically this is my, the most common or the most famous is HTTP. Then SMTP. There is a secure version of this as well, which is HTTPS. The network is basically for my IP address. So ICMP or some other protocols are working at this layer. At transport layer, the major ones that I have is TCP and UDP. This is basically my TCP and UDP, right? And then at a data link layer, I have MAC protocol. This is my MAC. Then I do framing as well and bit stuffing, right? The framing and bit stuffing is also done at this level. Now, let's see how from from request to the end, right? So let's see how and where each layer is going to come in. So basically, from request to receiving data. So how that flow is going to work, we'll see. First is basically my client at the client end, right? This is, I'm going to be running a browser here. This is my browser, right? So then I'll be going to type in a URL, right? Now when I type in a uniform resource locator, so the way it is written is, so first I need to mention, it will be like www, right? Starting. So now this is basically indicating that I'm using World Wide Web. So basically information will be transformed, or transfer will occur in the form of HTML, or in the form of hypertext, not HTML. Basically I'm going to do hypertext transfer over here. This basically indicates that the information is being transferred is basically going to be in the form of hypertext, right? So then here I have a go button. So when I click this button, so what is going to happen is basically first I'm going to go to my DNS resolver, right? So then I'm going to go my DNS. Now this DNS job, so remember this is in English, right? Our computers cannot understand English. So basically this URL will be in English. We need some mechanism to convert this English into numbers, right? So that job is basically taken care by the DNS. Now the DNS is going to return back an IP. Basically, my server IP address is what is going to be returned, right? Now there are two types. So basically of DNS, right? Um, one is my local DNS provided by the ISP, or it can be within the browser itself. So in the browser itself, you can configure the DNS. So now once I have the IP, now I have the actual address of where my server is located, right? So now this is my IP. So here now I have my IP back. Now I have an address, right? So basically a number is returned here. So now I need to go to the sir to that to the server at that address, right? So I'll be going to this. So first thing that is basically what we are going to do is um first is basically we are going to establish a TCP connection, right? So then we are going to establish TCP. So basically this TCP will work on IP, right? So hence it is the called as TCP IP because we are using IP to locate the server, right? So then that TCP three-way handshaking is going to be established. Now once that handshake is established or once the handshake is completed, so then is my HTTP request which is going to be sent out. So then is my HTTP request being okay. So then this is HTTP request being sent out. So now this is where all the information transfer is going to happen. So when I'm going to do the HTTP request being sent out, there are certain HTTP error codes as well, right? So I have an HTTP error codes basically which indicate error at the HTTP level. Now there is a secure version of HTTP which is called as HTTPS. There is one more version of this which is HTTPS. Basically, what this S stands for secure, right? So I'm going to do something called as TLS SSL signing. So this is basically secure. Basically, I'm going to do here my TLS or SSL certificate signing. That signing is basically going to make sure that I'm reaching to my server is the intended server and there is no man in the middle attack. Now once that is done, again this is going to work on top of HTTP, right? Okay, so now in the response what I'm going to get is, so in the response, so I have sent the HTML. The HTML has been HTTP request has been worked out at the server end. Now in response from the server, what I will get is, first from the server I will be receiving a error, a code number, code indicating what happened to my HTTP request that I sent. There are different types of HTTP code versions that are available. Now once that code has be once I get so basically I'll be receiving HTTP 200, right? Basically this is okay. Now then my server will now send the data in the form of HTTP, right? So from the server end I'll be getting data. So data is sent in form of HTML, in form of hypertext, not HTML. So once I have that data, so then I'll be so then is my where is my physical layer which is going to come into play, right? So using the physical layer is when I'm going to route that data using the physical media to the server, right? And then I'm going to perform some error correction mechanisms as well to check if there is any error that is going to be occur. So what we can conclude by this is the HTTP or HTTPS, they work on top of they work they work on top of TCP, right? So basically, for us to have HTTP and HTTPS communication or connection, the request to be sent out, first we need to establish a secure connection, right? So that secure connection is basically done by TCP, because UDP is a connectionless protocol, right? This is basically a connectionless protocol. However, we are going to do with TCP, right? And there are other ways of communication as well, right? For example, you have socket connections. Now, all of them first will involve a TCP connection, and then we'll be upgrading to some other form of communication, right? For example, we'll be going to socket or some other form, right? Now, then the next thing that comes us is basically cloud providers, right? So, what are these cloud providers? So, this is basically a software as a solution product kind of product, right? So, what cloud providers do is, so instead of us having or owning the physical server or any database, or what we do is we don't own them. Instead, we rent out from the cloud provider using internet. So basically, I'm going to use this is internet. Basically, so this is my suppose this is my server room, right? So this is going to be maintained by the cloud provider. The way I'm going to access them is on the internet, right? Now, cloud database is one example. You can have an server running, that is basically, now there are different types of cloud providers. So for example, you can have AWS, then you have Google Cloud, then you have Azure Cloud, right? These are the three main players. So even IBM has its own cloud. What the job of IBM Cloud is? It kind of has both physical and software products. So basically, the job of managing all these servers is basically the job of the AWS, right? We are just going to use them for our functionality. Now, the next thing that we need to understand is basically something called as content delivery, right? So even though we are going to access those cloud servers, even though we are going to use a cloud based server, this can be so this is server is going to be located physically in some part of the world, right? So for example, then that is nothing but when we say we have data centers, right? So by data centers, what we are meaning is these are physical centers where we have hardware. So data centers are basically physical centers for where we have hardwares, right? So you will be computing, you'll be having databases and stuff. We'll be having memory racks. So what we are going to do is, and then we are going to access the website from some other part of the world, right? And this data center, which is managed by AWS, will be located somewhere else, right? So what we are going to do is, there's some time that is going to occur for us to establish or to reach to the data center, right? So to minimize that data time or to minimize data center, what we do is basically we use something called as CDN or a computer delivery network, right? Now what this CDN does is, so basically it is a so suppose if I am in US, right, it's much easier for me to reach to a server that is already in US rather than to reach a server that is in some other part of the world. For example, in Europe, right? I have to travel across continents. But here it's easy. So what I do is I send this request and then I hit the CDN, right? Now what the CDN does is the CDN will kind of cache A CDN maintains a cache and it will store the HTML, CSS, and other files that we need for our website rendering, right? So this is basically it will be stored in my CDN, and then it will be cached in my CDN, and then I'll be just getting that data from the CDN itself. So by doing that, what I'm doing what I'm reducing is basically I'm reducing the transit time, right? So transit time is reduced. So hence you have, when you do an HTTP request, the response that you get is in milliseconds, right? So you want the response to be in milliseconds. Okay. Now um or in other words, what we do is we have something called as time to live, right? We update, or TTL basically. um Even though we are not using that website, there is a time for which it is kept active, that is basically called as, in another word, which is called as time to live, right? Okay. Now one example of CDN is the company that manages CDN is basically, um there are multiple companies. So one good advantage, or um um one good example of a CDN company is basically, it could be my Cloudflare, or then I could have CloudFront, right? It also allows us not to burden the. It basically kind of, um. So there is something called as DOS attack that happens. Basically, that is basically you now the server. If you think of a server, the server is a specialized computer itself, right? This is my server is nothing but a computer that whose job is basically to serve the request. So this is also going to be a server. So um this is this is also a server by itself. Um a server is basic nothing but a computer by itself. So a server is a specialized computer, you can say, that has some special powers, right? It is a specialized with special powers. Now, although it has special powers, but then you will be initializing your servers, right, with certain processing capacities. Now, what if you have too many requests being sent out, right? That could overwhelm the CPU, right, or the workers that are working, right? So these workers can be overwhelmed. So what we are going to do is, so if there is any new more request coming in, they will have to wait, and they are not going to be served. So basically, that is nothing but my denial. Basically, what I've done is I've denied them service, right? So this is basically the thing what called as denial of service attacks. Now, whenever you have any such incident, again, you are wasting a lot of resources, right? So what we do is basically we kind of navigate to a CDN. So once we get to a CDN, what additional function that we do is we can check whether you are a robot, right? So generally, whenever you reach a CDN, you do are you a bot kind of question, right? Are you a human? So we do that, are you a human question, right? basically we'll be solving some sort of puzzle or some captcha based something, basically to avoid that denial of service, right? Okay. And then from the what do you say, the CDN itself, we are going to check from the cache and then serve the request. So from the cache itself, we are going to give back the file that we need, that is HTML, CSS, or JS. Okay, so yeah, I guess um so um yeah, so I guess yeah, that is all for uh this lecture. We also see some IP address. Also, we also, when we learned about subnetting, um, the major goal or the major advantage of subnetting was basically to, so subnetting basically overcomes IP wastage, right? So we are doing subnetting to avoid IP wastage now. But then already we have so many like we already have so many devices, right? So there are total around 4 billion people who live on earth, right? So we are approximately having 4 billion people living, right? So that means we need approximately 4 billion IP addresses, right? So basically which we have like we are out of them, right? So this problem was potentially diagnosed before itself, and then what we did is we divided the IP into two types itself. So if you see your IP itself, there will be a two way or two classification of IPs. One is basically what do you say, a public IP. The other is basically going to be your private IP, right? So to avoid that problem as well, we have divided the IP into two types, public and private. Now, the whole idea of having this public-private partnership is basically to um avoid uh, basically to reuse IP addresses as much as possible, right? So now what we did is, so instead of the end, so IP is basically a 32-bit value, right? So instead of us using the entire range, we have restricted some IPs, as some will be a private IP. So then, so for example, the range of 10.0.0.0 to 10.255.255.255, right? These are basically reserved. This is my reserved IPs. Even there is one more IP address that we have reserved, right? That is 127. The entire range has been reserved. This is basically for my loopback address. That means um, so now whenever I have these two IP addresses, right, data is not going to, the request is not going to come out. This is basically not coming out. So now how does this, there is a way in which we do the public to private address management, that is done by NAT, right? So your router or your modem, whatever you have, that has that network address transpiler or record maintainer, right? The main job of that NAT is basically to do this public private mapping. Now that's hence when we run a speed test, now what you are actually doing is, so for example you are running a speed test, right? So suppose this is my device, right? So then I'm going to run a speed test. So by speed test, what I'm doing is I'm just sending an empty packets, and then I'm sending and making sure when are my packets reaching me, or what is the downtime, or how much time are they is my package taking for me, for them to reach to me. This is nothing but how my public this is basically what is going to happen, right? When I so basically one arrow is I'm going to be sending empty packets, and then I'm just going to wait for how for the response of these empty packets, right? So this is basically what I'm doing, right? I'm sending empty packets, and I'm sending empty packets and then waiting for response. Now whenever you do a speed test, right, so you will get two types of IP in there as well. I mean, it will either so what when we do a speed test, what are we doing? So let's try running a speed test. So let's go to, there are so many websites. Just go to speed test, and then this is when we do an Okla, you get some IP, right? So this will be don't never allow. So there is one more what do you say? There is one more range that is reserved for public. That is that the 197 range. So even the 197 range is no, there is however when you have a local network oh yeah, there is 192, so not 197. Is 192 reserved, or we saw 10 point, the entire 10 series has been reserved. There should be one more, yeah. So 192, that entire series is again is also a reserved IP. So you have one more thing that is, so in addition to this, okay, let's oh no, this is, yeah, we were here, right? So we were seeing IP addresses. So we saw that at 10.0.0 range is reserved. Just to add to this, there is one more reserved address, which is the 192 range is also reserved. Yeah, 192. That is also being reserved, right? These are private IPs. So the moment you are on these IP, it's basically an internal IP, like a network, local private network. And for larger, you have larger networks, like you can connect more basically devices, right? By uh, by changing that IP range is basically you're having more accessibilities or more accessible devices. Now, so now how does speed test work? Like, so yeah, so basically what I'm going to do is it's my modem speed test that is going to come, right? So basically this is going to be my so when we do a speed test, what I'm going to do is I'm going to send. Now there are different servers, right? For example, Okla has its own servers. You have Okla. Then so many companies have powered with like have partnered with Okla. So when you do Okla, for example, in Canada you have an ISP called as Shaw, right? So we kind of have partnered with Okla. Even though we are using the R servers, so whenever we are going to hit that website, the DNS is going to give me so it will be this it will be like rogers.speedtest.ca, something like that. So that is that DNS routing is going to take ultimately on the back is Okla server being running. But yeah, so for different companies you have different servers. So Google has its own if you do speed test server as well, you can do. So basically Google also provides its own. This is basically decided at the DNS level, right? The DNS we have each record to address mapping present, right? So whatever URL we enter and correspondingly packets we are going to get. And this is going to occur at the modem level, right? Remember, this is the actual modem speed that we are getting. Okay, so I guess that is all for TCP IP. There is UDP as well, but most devices or most web apps will be using, or even if it's a mobile web app, you will be using TCP IP sort of a connection, right? So right now it's not that important. So UDP is something where connection is not needed. You do not. So HTTP is not what is required for UDP. There are other protocols as well. Um. So yeah, that is all for computer networks. I have covered I covered almost all topics that you would need. So one is how the other two three topics that are left is basically socket, right? Now socket works on TCP IP. It's like TCP IP upgraded to socket. We'll see that in action when we write some code. So that is all for the session. I hope you guys liked it. Please subscribe and yeah, please subscribe. A lot of people I see haven't subscribed, so please subscribe. And we'll see you guys in the. I'll see you guys in the next one. Till that time, take care. Bye bye.